Hi, welcome back to another episode of Algebra in Words, the video series. We're continuing our discussion on absolute value inequalities. And I went over an overview of the method we're about to do, which is the test point method, as well as an overview 2 videos ago. And in the previous video, we looked at doing the keep, change, change method. But in this video, we're going to do one more example of the test point method. So let's get started. Up here I have an absolute value inequality. It's got the absolute value and the inequality. And in 2 videos ago I gave an overview of the method, so I'm going to assume that you know the method by now. And so basically, let's get started. The first thing that we're going to do is convert the inequality into an equation by converting the inequality symbol to an equals. So let's make this x minus, the absolute value of x minus 1 equals 3. And then what we're going to do is make a positive and a negative. So let's do the positive up here. And to do that, we're going to keep this the same, x minus 1 equals, and keep this the same, 3. And let's simplify that. Plus 1, x equals 4. And now let's do the negative form down here. So we're going to have x minus 1 equals now negative 3. Plus 1, and we get x equals negative 2. So these are our boundary points. And let's put that down here. So we solved and we got x equals 4. Let's plot that here. And x equals negative 2. Let's plot that here. These are our boundary points, which we just plotted on a number line. And if you like to, you can draw dotted lines. But for now, I'm not going to do it because let's get used to it without it. But if it helps you, draw the dotted lines. Now, we're going to define each of the 3 regions that are split up by our just found boundary points. So over here, we're going to have negative infinity. And this symbol is non-inclusive, so that's going to make this negative 2 with the parenthesis, not a bracket. The middle region is going to be negative 2, comma, 4, parenthesis, because it's non-inclusive. And the region on the far right is going to be 4, comma, infinity, parenthesis. And now, let's choose a test point for each region, keeping in mind the test point cannot be the boundary point. So, what's a good number, test point, less than negative 2? Let's choose negative 3. And I'm just going to circle that to highlight it. What about between negative 2 and 4? Choose 0. And what about greater than 4? Choose 5. We're going to take each of those 3 test points, one at a time, substitute it back into the original inequality, and analyze the outcome. So let's start with negative 3. And negative 3 and for x, negative 3 minus 1 is negative 4. And let's just move it to the right. When you take the absolute value of negative 4, it becomes positive 4. Is 4 greater than 3? Is that a true statement? Yes. So what does that mean? We keep the region that that test point comes from for our final answer. Let's now test 0 for the middle region. Plug it into the original inequality. 0 minus 1 is greater than 3, and 0 minus 1 is negative 1. Let's move it to the right, and the absolute value of negative 1 is positive 1. Is positive 1 greater than 3? No. So that means we cross out and reject the region that that test point 0 came from. And now finally, let's test point 5. So we're going to substitute 5 in for x in the original inequality. 5 minus 1 is greater than 3. 5 minus 1 is 4. And the absolute value of positive 4 is positive 4. And is positive 4 greater than 3? Yes, that's a true statement, yes. And yes means keep the region that that test point came from. Now, since we have two regions, put a U for union between them for the final answer. So let's see if I can fit that in below here. Parenthesis negative infinity, comma negative 2, union 4, comma infinity, parenthesis. And let me circle that so you can see it. And that's the final answer. Thanks for watching, and I'll see you in the next video.